Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study what is Introduction to Friction module, that is the friction topic. So far, we have covered definitions and terminology related to friction. In definition terminology, there are various definitions such as what is the friction, what is the limiting friction, what is the coefficient of friction, etc. And also one more session also we covered what are the applications of the friction in daily life and also engineering point of view also. In engineering point of view. Now let us begin. What is the introduction of the friction? The friction here, it is nothing but here, the way it is mentioned scientifically that if a block of one substance is placed over the level surface of the same or different material, a certain degree of interlocking of the minutely projecting particles takes place. So the meaning is that if the block of one substance is placed on another, what will happen? A certain degree of interlocking takes place. That interlocking of the minutely projecting particles between these two surfaces. The surface one having minute projections will be there, and surface 2 also having minute projections will be there. So when you are keeping on that, it will be certain interlocking. Now, this does not involve any force. So as long as the block does not move or tends to move, so it will be in stable condition. Now, the point is that when one of the block moves or tends to move tangentially, with respect to another surface on which it rests. So the interlocking property of the projecting particles, this projecting particles opposes the motion of the another body. Okay, this opposing force which acts in opposite direction of the movement of the block is called force of friction or simply friction. Now let me explain very simple, step by step. You are keeping, this is one body, this is another body. You are keeping on your place. Each body is having particles. Here the projections on the surface are the minute particles will be there on each other surface. So it does not involve anything, any force, as long as it doesn't move. The moment one body, this is idle body, the bottom hand is the idle, the top hand is ready to move or tends to move. Immediately these particles opposes the force. But when you move more portion, what happens? This force acts in the direction of the opposing. If the body is moving in this direction, the friction force is opposite to the direction of the motion of the body, that is the top body. That force is known as friction or frictional force. Okay, based on this concept, you can see it, how the mopping of the floor. Okay, and also some examples. You are brushing your teeth. Your teeth are in static condition, and brush is moving in motion condition. So what will happen? These particles try to move. Okay, it opposes the force. So wiping the floor, writing by pen on the paper, like that. These are the applications of the force. Now, what are the types of friction? There are various types of frictions are there. The number one types of there are two types of frictions. Number one, static friction. Another one is a dynamic friction. So now, what is the static friction? The static friction, it is the friction experience. It is the friction means frictional force. Alright. It is the friction experienced by a body when it is at rest. Or in other words, it is the friction when the body tends to move. That is also there. Tends to move, not in motion condition. It is ready to move. Tends to move or at rest. So this friction come into the picture. So static friction can be measured by using a quantity. What is the factor? That factor is known as coefficient of friction. Coefficient of friction. Coefficient of friction. So here static coefficient of friction, that is denoted by mu. What is the unit? Unit for coefficient of friction? It is the coefficient. That's why not only it is a coefficient, it doesn't have any units. It is the factor with a number. Okay, the coefficient of friction is denoted by mu, and unit is, it is unitless. Now, next one is called dynamic friction. What is the next one? What is the dynamic friction? It is the friction experienced by a body when the body is under dynamic condition. That means under when it is in motion, function of time. This dynamic friction is also known as kinetic friction. So, the dynamic friction is again two types. Number one, sliding friction. Another one is rolling friction. Under sliding, it is also under motion, moving condition. The body is in moving condition. Under rolling condition, under rolling of the body, under rolling also it is under motion. That's why this is sliding and rolling are come under the category of dynamic friction. So this dynamic friction is also known as kinetic friction. Kinetic friction is again divided into two types, that is known as rolling friction and sliding frictions. Now, the friction can be here, you can make it as in simple diagram. The friction, two types. Number one, static friction. Number two, dynamic friction. Again, dynamic friction is two types. Number one, sliding friction. Number two, what is the second subcategory? That is a rolling friction. Rolling friction. Now here, this dynamic friction is also known as kinetic friction. Is also known as kinetic friction. Okay, these are the main overall view of what are the types of frictions. Now coming to the sliding friction, what is the meaning of sliding friction? When the body is under sliding condition, the frictional force is known as a sliding friction. It is the friction experienced by a body when it slides over another body. What is a rolling friction? Yes, it is experienced when your body is under what condition? A rolling condition. So this rolling friction can be experienced. You can see it. You can observe this rolling friction here when two-wheeler or four-wheelers are moving. This is a wheeling wheel onto the road. They are having under condition. The contact between the tire and the surface, that coefficient of friction is known as rolling friction coefficient. And here the frictional force is the frictional force is known as the rolling frictional force. So what is the mean sliding friction? The sliding friction takes place here in simple example here, and the slider, when the child is ready to move, is sitting and moving in sliding condition. So that frictional force between the surface, the body of the child, the body of the person, and the surface of the slider, that frictional force is known as sliding frictional force. Now, coming to here, coming to limiting friction, there is another term, is very, very important, this limiting friction. So here, the limiting friction, the definition of the limiting friction is that the maximum value of the force which comes into play when your body just begins or tends to move or slide over another surface of the body, that is known as limiting friction. Okay, it is the maximum frictional force is required. It is the initial. Okay, the maximum value of the frictional force. Now when it comes here, a limit beyond which the force of friction cannot increase. Beyond which the force of friction cannot increase. It is the maximum frictional force. Now, if the applied force exceeds this limit, the force of friction cannot balance it and the body begins to move in the direction of the applied force. So this maximum value of the frictional force which comes into play when your body just begins or slide over the surface of the other body is known as the limiting friction. Okay, let me take example. You can understand it better. This is the surface and the body you kept. On another. Okay. Now the frictional force, now you apply. The weight is, suppose it is 100 newtons, or you can call it as 10 kgs. Approximately it will be on round figure, that is 100 newtons. It is the weight of this body. Now, if you apply the force F, the value of the F is, suppose here, 1 Newton. Will it, the body will move or not? No, it won't move. Now, if F equal to 10 Newtons, will the body is able to move? No, because the weight of the body is more than the applied force 10 Newtons. Now, this is the weight W. If value is 99 Newtons, will the body tends to move? No. If F is 100.1 Newton, then the body tends to move. If, that is the meaning, if F is greater than W, then what will happen? The body tends to move. Up to that, the body doesn't move anything. So here, the frictional force you apply such a way that, the F you are going to apply such a way that the maximum value of the condition, the body tends to move, the direction tends to move in the direction of the applied force. But if you coming to the between the what is happening, the mechanism, the process goes on between the surface and weight of the body. Here, the body surfaces, between two surfaces, the body tends to move. That able tends to move or able to begin to move, the maximum value of the frictional force occurs. It is the initial stage. You have to apply more. Once it is under motion condition, no need to apply every time 100 newtons. It is already under motion. You need initial stage F is greater than W. After under the motion of the body, okay, that is under the motion, the F can be less than W, but the W can move. Here, initial stage at the limit at which the body begins or tends to move, the frictional force is known as the limiting frictional force. That frictional force is the maximum value of the frictional force. Why maximum values comes? Why not small value? Because there is lot of inertia in motion at initial stage. That inertia obstructs the body not to move. So to overcome that inertia plus the weight of the body, so we need more force. That frictional force is known as a limiting frictional force. Okay, that is the concept of limiting friction. Now there is one more sentence here mentioned here. What is that? Here, if you see that the maximum value of the limiting, it is the maximum. After that, the frictional force will be low, decreases. Somewhere else here, yes, the first sentence you see. A limit beyond which the force of friction cannot increase. Yes. It is very simple. When the vehicle is, to understand this concept, suppose there is a two-wheeler. This two-wheeler vehicle okay, it is initial condition, not under motion condition. Due to some engine problem, it is under initial condition. It is under stable static motion. But sometimes have you seen when the people applies the force, gives motion, after that ignition begins. Okay, because driver starts ignition, that ignition starts, vehicle will move. But if you are going to it is under static condition, you need more force to move this vehicle. You need lot of force. Once it is under initial condition, you have to move first in this direction. What to do? You have to move first initially, then you have to give up. Again it comes back. Then you have to move on. Okay. Once it is under motion, you need less force to move this body. It is under motion condition. It is not yet started the engine. But the vehicle and is under motion, you need less force to move the vehicle. Here I consider why initially more force is required. There is a lot of inertia plus weight of the body vehicle. The force you apply is such a way that the value of the force should overtake the weight, at the same time inertia. Now, point is that at that point you need more frictional force occurs. That will be the maximum value. That is known as the limiting frictional force. Okay, that is the concept of limiting friction. Further, we'll explain better what is the limiting friction here. It may be noted that, let me read, when applied force is less than the limiting friction, what will happen? When applied force is less than the limiting friction, the body remains at rest. And the friction is known as static friction. Okay, it may be having any value between the 0 and the limiting friction. Why? Under static condition. Now here, the body is on the surface. Okay, weight is acting downwards. Weight acts downwards. Now, there are certain terminologies are there. This is the thrust you applied. Thrust in this direction. And there is a movement of the body in the direction of the thrust force. The direction of the thrust, there is a movement. Next, the weight is acting downwards. And there are two terms is there. The maximum value at which the body tends to move. That is known as the limiting friction. Here, the third term is known as normal reaction. When weight is acting downwards, there is an equal and opposite reaction. That reaction force acts collinear with the direction, in collinear or in the action of the weight, but in opposite direction to the weight. Now, that is known as, what is the normal reaction? Normal reaction always acts, another property is known as, the characteristics of normal reaction. It always acts in opposite direction to the weight, but normal to the surface. In the 90 degree, it acts upwards, but it is normal 90 degree to the surface. Suppose, one more example. It is a horizontal plane, that's why it is 90 degree. What about inclined plane? Okay, you may say that it is exactly in the direction of the weight I said. In the case of, that is only in the case of when the body is on horizontal surface. It is on inclined surface. The weight always acts vertically downwards in spite of whatever plane may be. What about normal reaction force? The normal reaction acts normal to the surface. This is the normal reaction. N or R. It is denoted by N or capital R. Is the weight W. The angle of inclination is theta. Okay. In this manner, this is normal reaction. Always acts normal to the surface. And one more thing is that if the surface is in this direction, it is the surface inclination is theta. And here on this, if there is a body, if we kept, it is the body, the weight acts downwards. What about normal reaction? The normal reaction acts normal to the Normal reaction is normal to the surface. Okay. Now, that is the limiting friction concept. Now here, the limiting friction, very simple manner, we can also explain the limiting friction. What is the definition of limiting friction is that limiting friction is the maximum friction force can be developed at the contact surface. That is when the body is just on the point of moving is called limiting force of friction. We'll call it limiting friction. What is that limiting friction? Is this limiting friction coefficient or limiting frictional force? Yes, it is the limiting frictional force. It is not a limiting coefficient of friction. Now here, what is the unit of limiting friction? The unit of limiting friction is newtons. What is the weight? The weight unit is that unit of the weight is newtons. And thrust unit is newtons. Normal reaction unit is newton. Now this is the limiting friction newton, weight is newtons, all are newtons. Whatever the unit for movement, if the displacement means it is in millimeters or meters. Okay. The next, here there are certain laws are there in order to understand the limiting friction. Instead of always saying limiting frictional force in a short form, we're going to tell limiting friction. Now here, what are the laws of limiting friction? If you understand the laws of limiting friction, that is very, very important in order to calculate the quantity of the friction force in terms of the coefficient factor, that is the coefficient of friction. Now, what are the following laws? The following laws means here, the direction of the limiting friction force, the direction of limiting friction force and the direction of the motion is always opposite direction. Limiting friction force which is acting opposite to the direction of what? Motion. If the body is moving in the direction, because in the direction of the thrust body moves, but whatever limiting frictional force, it acts in opposite to the movement. That is the first law of a limiting friction. The second law of, what is the second law? The limiting frictional force is always acts tangential to the contact surfaces. It is in tangential. The contact surface, if you understand, here the contact surface, here this is the one contact surface, this is another surface. The tangential, it is in tangential to the surface. Yes. The limiting frictional force acts in opposite direction of the motion. The body is moving in this, the limiting friction moves in that direction, but it acts tangential to the contact surface. That is the second law. The third law is that the magnitude of the limiting friction and the normal force between the two surfaces are directly proportional. The magnitude of the limiting friction and the normal force between the two surfaces are directly proportional. And the fourth one is that the limiting friction is very, very important. It is very, very important. The limiting friction is dependent on, and what are the independent also? Dependent on the material and the nature of the surfaces that are in contact and the smoothness. Okay, that is the fourth principle. And fifth principle, fifth law, what is the independent? This limiting friction force is independent of what? Independent of, limiting friction is independent of the shape and the area of the surface. Shape and area. But it is dependent on material, the material which it is in contact and the nature of the surfaces. What is the nature of the surfaces? It is the smooth surface or roughness surface. Okay. And the contact, nature of the surfaces that are in contact. So that contact here, the coefficient of friction, the contact is point contact. There are various types of contacts between the two surfaces. So here, the contact is that when the surface, I am considering the constant surface, I will change the body one is the surface, one is the constant, it is the body one. And the body 2 is suppose if is a, okay, is a complete contact. The contact is that, what type of contact? It is the area contact. Another contact is that the body 1, another, it is a wheel, it is a body 2. The contact between body 1 and body 2 is a point contact. It is a point contact. Yes, it is dependent on the type of contact. And another one, if you can also make it as 2 surfaces, elliptical contact also. Okay, one body is in touch with another body is in ellipse formation, elliptical contact. Now the point is that the nature of the surfaces, what is the nature of the surface that are in contact? But here the point, another one, it is independent of the area of the surfaces. What type of area may be, it is independent. But here the point, one more thing, what is the type of materials and the surface smoothness. If the surface is rough, more friction in comparison to smooth surfaces. The rough surface, the coefficient of friction is high. If it is smooth surface, the coefficient of friction is low. Okay, that's why it is dependent on limiting frictional force is dependent on type of surface and the smoothness also. So these are very, very important laws. There are total 5 laws are mentioned here. The first law is the direction, and second law indicates what is the what is the tangential, is this tangential or normal. The third one is related to the magnitude, and the fourth one is dependent. What are the dependent parameters? Limiting a friction force depends. And finally, fifth one is that independent action. What is the independent properties? It depends on it is independently acts. So these are the 5 laws of friction, very, very important laws in order to quantify the frictional force in terms of quantify the friction by using in terms of the coefficient of friction. If the coefficient of friction is high, that means in comparison to there are 2 surfaces are there. One is rough surface, another one is smooth surface. In rough surface, the contact between 2 surfaces, the coefficient of friction is high in comparison to the smooth surface. So we can tell just by inspection, by naked eye, but the point is that what type of force we are acting. So these are the calculations we will see, both horizontal surfaces and also on inclined surfaces. Now, these are the certain examples of limiting friction. What are the examples of limiting friction? We are going to talk. Now here, some examples mentioned here. So when we walk on the road, this is one of the example. Due to frictional force, we are able to move forward. We are able to walk. Otherwise, we will be at the same place. Because of when coefficient of friction is 0, we will be there. So when a car moves on a cliff, yes, coefficient of friction, it is another example. Another example is that frictional force applied by upstream of water to a swimmer. Yes, frictional force. And frictional force on a pen by a page or notebook, and moving an object on the ground, and a car parked on a hill will not slide down. This is because of the value of the limiting friction is high enough to ensure that the car is in a state of rest. The limiting friction force is directly proportional to the mass of the object. And next one is that pushing a heavy truck seems very difficult due to the high value of static friction. And finally, when we push any object, we encounter static friction for some time until the value of the limiting friction is reached. After reaching the value of limiting friction, the friction force will be low, decreases, and body able to move. The next term, very, very important, is that we spend more time in limiting friction. Next one is the normal reaction. What is the normal reaction? So it has been experienced that whenever a body lying on a horizontal or inclined surface is in equilibrium, its weight acts vertically downwards through its center of gravity. I am considering here there is inclined surface. Okay, to understand better for you. In the horizontal surface, what will happen? The direction, the line of action of the weight and normal reaction, both are same. It is a collinear. Whereas in inclined surface, it is not in collinear. You can understand the difference between normal reaction and weight of the body. Now, the weight of the body acts through its center of gravity. As I mentioned, before. Now, it acts vertically downwards, passing through its center of gravity. It is CG. The surface in turn exerts an upward reaction on the body. This reaction, which is taken to act perpendicular to what? The plane, is called a normal reaction and is generally denoted by R or capital N. According to this point here, this sentence, it acts, there is normal reaction. That normal reaction is normal to the surface. What is the angle between the plane and the direction of the reaction? That is 90 degrees. It is, one more thing, it will be interesting to know that the term normal reaction is very, very important in the field of friction, as the force of friction is directly proportional to it. Okay, the force of friction is directly proportional to N. Okay, then that constant of proportionality we are going to find out here is known as coefficient of friction. Now, by considering, as I explained, on a normal inclined surface, now here it is horizontal surface. I consider horizontal surface is the body 1 and it is the body 2. It is body 2. Now, the weight of the body acts passing through the CZ downwards. Whatever normal reaction, there is a reaction which is normal to the surface. This is the surface which acts upwards. The normal reaction is the weight. Okay, here, as I mentioned before itself, the limiting friction and the thrust. So the movement of the body is always in the direction of the thrust. Next, it is the diagram which represents relation between the friction and applied force. Now, here it is moving. There are two zones are there. Here, before the limiting friction, it is known as the static friction zone, and after the limiting friction, it is known as the kinetic friction or dynamic friction zone. Between the junction point is the limiting friction. Before that, when the frictional force you applied, when the frictional force or when the thrust you applied, the body begins to move just like that. That is known as the maximum value of the friction. Yeah, that is a limiting frictional force. Up to that, the coefficient of friction is known as static friction. That is known as coefficient of static frictional or static frictional force. Coefficient of static friction. After reaching that limiting frictional force, the coefficient of friction, yes, frictional force up to this is the maximum frictional that. After that, you can understand how it is getting reduced in kinetic friction. If speed increases more and more, it goes down, down. And it can't be zero. Because if it becomes zero, what will happen? Becomes under sliding condition. Yes. Here, the condition is known as the rolling condition. In the kinetic, again, what type of condition? Rolling. The sliding means skidding takes place. So, when it is moving, what will happen here? This is a rolling. After the rolling, suppose you applied a lubricating oil on the road, on the surface. What will happen? The sliding takes place. What is the coefficient of friction? Becomes zero. Or, due to rainy, water will be there. Water acts as a thin layer between the contact surfaces. Such a way that this water also acts as not only lubricating, the car makes to slide of one body to another on another body. There, the sliding friction. Now in that manner, it is very important here, the relation between how the static friction and the limiting friction and kinetic friction in relation to the friction and applied force. Alright, next, the angle of friction. What is the angle of friction? Here, the angle of friction is here. The angle in this figure, you can understand, this alpha is known as the angle of friction. Now, the angle of friction gradually increase till the body just starts to slide down the plane. This angle of inclined plane at which a body just begins to slide down the plane, it is known as the angle of friction. Here, the angle of inclination, initially what we will do, this increase the angle, we kept the weight on the plane just to reduce the angle alpha. Then it doesn't slide down. Slowly increase the angle of alpha from 10 to 20, 20 to 23, like that slowly. At some angle, the body begins to slide. That angle is known as angle of friction. So this is also equal to the angle which is normal reaction makes with the vertical. Now, finally, we are going to understand how the friction will be quantified. That is known as the coefficient of friction. It is a ratio of a limiting friction to the normal reaction. Okay, between two bodies. Limiting friction is known as what? Maximum frictional force. That to the normal reaction. That mu equal to F by R. So F is proportional to R. That F equal to mu times R. This mu is known as constant of proportionality. Then mu equal to F by R. Where what is the F is? It is not a thrust. It is the limiting maximum frictional force. That is limiting frictional force. So what is the here? In terms of mu can be measured coefficient of friction. Another one is called angle of friction. That is called mu equal to F by R. That equal to tan phi. Where phi is the angle of friction, F is the limiting friction, and R is the normal reaction between two bodies. It's very simple. Now, finally, the loss of friction. Here, the loss of friction, limiting friction you have studied. Now, here the Professor Coulomb, after extensive experiments, he gave some loss of friction which may be grouped under the two heads. One is loss of static friction. Another one is loss of kinetic or dynamic friction. Now the loss of static friction, as here, loss of, again, now coefficient of friction, we have studied. The coefficient of friction mu equal to F by R, that is known as F by R equal to constant. Now, what are the loss of static friction? The loss of static friction are here. The force of friction always acts. The force of friction is always acts in a direction opposite to that in which the body tends to move. Or if the force of friction would have been absent, okay, the tendency of the force of friction is always in a direction opposite to the direction of the motion of the body. Next, the second loss of static friction is the magnitude of friction force is exactly equal to the force which tends to move the body. And the third one is the magnitude of limiting friction force bears a constant ratio, that is known as a coefficient of friction between constant ratio or to the normal reaction between the two surfaces. Mu equal to F by R, that is remains constant ratio, that is known as the constant ratio, that is coefficient of friction. Next, the force of friction is always independent of the area of the contact between the two surfaces. Next, the force of friction depends on what? Roughness of the surfaces. Okay. Next, the loss of dynamic or kinetic friction. So what is the loss of dynamic or kinetic friction? The force of friction always acts in a direction. Again, same. This is the point. First one is the same, in which the body is moving in a direction in opposite to. Always the force of friction is always in opposite to the direction of the motion of the body, whether it is in static condition or it is in kinetic condition or under dynamic condition. Next one. The magnitude of kinetic friction bears again constant ratio to the normal reaction between the two surfaces. That is known as the constant ratio is known as coefficient of friction. That is mu equal to F by R. but this ratio is slightly less as in comparison to in the case of limiting friction. This kinetic friction or dynamic friction value is less than compared to limiting friction condition. Next, for moderate speeds, the force of friction remains constant but decreases slightly with the increase of the speed. When speed increases, and the coefficient of friction will be reduced. Okay, so very important. Now here, what is the equilibrium of a horizontal surface? Here now we are coming to solving the concepts of horizontal plane and inclined plane. Now further, when your body is lying on a horizontal plane, it will remain equilibrium. But whenever your force is applied on it, what will happen? The body tends to move or able to move, begin to move in the direction of the force. In such a cases, you apply the force F. What happens in this direction? It tends to move. So equilibrium of the body first by resolving the forces horizontally and then vertically. Now the value of the friction force is obtained from the reaction. What is the value of the friction force will be obtained? The value of the friction force is obtained by considering the reaction that F equal to mu or relation. Here the concept is that now suppose when the body is here, you applied on the horizontal surface, you applied some force with inclination, the angle theta. It is not angular friction. Okay, alright. In which the direction force is applied. Now what will happen? This F should be resolved. That is the module 1 concept. Resolved into two components. What are the two components are? One is F cos theta. Another one is F sin theta concept. This F cos theta makes two body to move horizontal force. Okay. So we'll study furthermore in next session. Let us begin here. In this session, let me summarize what are the things we have studied in relation to the introduction of the friction. The friction means it is a frictional force. Limiting friction means a limiting frictional force. We have studied what is the friction, what is the thrust, what is the coefficient of friction, what is the limiting friction. We spend more time limiting friction and the loss of limiting friction and the types of frictions. One is static friction, another one is dynamic. Another name of dynamic friction is known as kinetic friction. Again, dynamic friction is categorized into two parts. One is sliding friction, another one is rolling friction. And what are the laws of static friction? What are the laws of dynamic friction? The common laws between the static and dynamic frictions are what? The direction of the frictional force is always in opposite to the direction of the motion of the body. And the frictional force remains constant between the constant ratio, that is mu equal to F by R. That is mu, the constant is known as the coefficient of friction. Initially, in static condition, it remains the same, whereas in dynamic condition, it is maximum, but after that, it reduces. In the case of kinetic condition, the point is that the limiting friction is always the maximum value of the friction in comparison to what? Dynamic friction value. So with that, we are going to stop this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.